When working with 500 kcmil copper cable and preparing it for termination in lugs or breakers, the precise number of strands to cut off can differ based on the specific lug or breaker being utilized. However, there are some general guidelines that can be helpful. For lugs, when dealing with 4/0 AWG and larger cables, a common practice is to cut off 6 strands per phase. For 250 kcmil and larger cables, cutting off 7 strands per phase is often recommended. When connecting to breakers, the recommendations change slightly. For 4/0 AWG and larger cables, it's advisable to cut off 4 strands per phase. For 250 kcmil and larger cables, cutting off 5 strands per phase is generally the guideline. It is absolutely crucial to always consult the manufacturer's instructions for the specific lug or breaker you are using. These instructions take precedence, as the number of strands to cut off can vary significantly depending on the design and requirements of the equipment. When cutting strands, it's important to ensure that the strands are cut off evenly around the circumference of the cable. This helps maintain the cable's circular shape and ensures a uniform distribution of current. Use a sharp tool such as cable cutters to make clean cuts. This prevents fraying of the strands, which can compromise the connection's integrity. After cutting off the necessary strands, twist the remaining strands together tightly. This forms a solid, compact connection that fits securely into the lug or breaker. This process can ensure a safe and effective electrical connection. Firstly, understand the cable size. The cable size, such as 500 kcmil, refers to the cross-sectional area of the conductor. Kcmil stands for thousands of circular mils, a unit used to measure the area of wires. Secondly, identify the type of termination you are making. Distinguish between lugs, which are used for connecting cables to equipment or other cables, and breakers, which are protective devices that interrupt the flow of current in the event of an overload or short circuit. Thirdly, consult the manufacturer's specifications. Always refer to the manufacturer's instructions for the specific lug or breaker being used. These instructions provide the most accurate information on the number of strands to cut off, as well as any other specific requirements for the connection. Fourthly, prepare the cable. Before cutting any strands, ensure that the cable is properly prepared. This includes stripping the outer jacket of the cable to expose the conductors and cleaning the conductors to remove any dirt or debris. Fifthly, cut the strands evenly. When cutting off strands, distribute the cuts evenly around the circumference of the cable. This helps maintain the cable's circular shape and ensures a uniform distribution of current. Sixthly, use a sharp tool. Use a sharp tool such as cable cutters to make clean cuts. This prevents fraying of the strands, which can compromise the connection's integrity. Seventhly, twist the remaining strands tightly. After cutting off the necessary strands, twist the remaining strands together tightly. This forms a solid, compact connection that fits securely into the lug or breaker. Eighthly, inspect the connection. After making the connection, inspect it carefully to ensure that it is secure and that there are no loose strands or sharp edges. Ninthly, torque the connection properly. Use a torque wrench to tighten the connection to the manufacturer's specified torque value. This ensures a secure and reliable connection. Tenthly, test the connection. After making the connection, test it to ensure that it is functioning properly. This may involve using a multimeter to measure the voltage and current at the connection, or using a thermal imaging camera to check for hotspots. Additional considerations to think about include the type of conductor. Copper conductors are more ductile and easier to work with than aluminum conductors. Aluminum conductors may require special preparation techniques, such as the use of an antioxidant compound to prevent corrosion. Also, the voltage and current rating matters. Ensure that the lug or breaker is rated for the voltage and current of the circuit. Using an incorrectly rated lug or breaker can lead to overheating, arcing, and even fire. Another factor to consider is the environmental conditions. If the connection is exposed to harsh environmental conditions such as moisture, chemicals, or extreme temperatures, use a lug or breaker that is specifically designed for those conditions. The tools you use can be important. Use the correct tools for the job. Using the wrong tools can damage the cable, lug, or breaker, and can also be dangerous. Here are some of the consequences of improper strand cutting. Firstly, reduce current carrying capacity. Cutting off too many strands can reduce the current carrying capacity of the cable, which can lead to overheating and voltage drop. Secondly, increase resistance. Cutting off strands can increase the resistance of the connection, which can also lead to overheating and voltage drop. Thirdly, loose connections. Improperly cut strands can lead to loose connections, which can cause arcing, sparking, and even fire. Fourthly, equipment damage. Loose connections can also damage the equipment that is connected to the cable. Fifthly, safety hazards. Improperly made connections can create safety hazards, such as electric shock and fire. When selecting lugs and breakers, ensure that the lug or breaker is compatible with the cable size and type. Using an incompatible lug or breaker can lead to a poor connection and can also be dangerous. Also, ensure that the lug or breaker is made of a compatible material. Using dissimilar metals can lead to corrosion and can also compromise the connection's integrity. A few additional points to remember are that firstly, safety is paramount. Always disconnect the power before working on any electrical equipment. Secondly, follow instructions. Always follow the manufacturer's instructions for the lug or breaker being used. Thirdly, get help when needed. If you are not comfortable working with electrical equipment, get help from a qualified electrician. Now, let's delve deeper into the specific considerations for lugs and breakers when dealing with 500 kcmil copper cable. When using lugs, you're essentially creating a mechanical and electrical connection point between the cable and a piece of equipment, a busbar, or another cable. The lug must be properly sized to accommodate the 500 kcmil cable, ensuring a secure fit. A loose connection can lead to increased resistance, heat generation, and ultimately, a potential fire hazard. The material of the lug is also crucial. Copper lugs are typically used with copper conductors to prevent galvanic corrosion, which can occur when dissimilar metals are in contact in the presence of an electrolyte, leading to deterioration of the connection. When attaching the lug to the cable, you'll typically use a crimping tool designed for the specific size and type of lug. The crimping process creates a strong, permanent bond between the lug and the cable, ensuring reliable current flow. Some lugs also require the use of a specific die in the crimping tool to achieve the correct compression. Following the manufacturer's instructions for the crimping process is essential to ensure a proper connection. Now, let's consider breakers. Breakers are designed to protect electrical circuits from overcurrents, such as those caused by short circuits or overloads. When connecting a 500 kcmil cable to a breaker, you need to ensure that the breaker is rated for the appropriate current and voltage. The breaker terminals must also be sized to accommodate the 500 kcmil cable. Some breakers have terminals that are specifically designed for larger conductors, while others may require the use of adapters or reducers. As with lugs, it's crucial to follow the manufacturer's instructions for connecting the cable to the breaker terminals. This may involve tightening screws or bolts to a specific torque value to ensure a secure connection. Over-tightening can damage the terminals, while under-tightening can lead to a loose connection. Now let's talk about some common mistakes to avoid when working with 500 kcmil cable. One common mistake is using the wrong size lug or breaker. This can lead to a poor connection and can also be dangerous. Always double-check the cable size and the lug or breaker specifications before making any connections. Another common mistake is not properly preparing the cable. This includes stripping the outer jacket too far back, nicking the conductors, or not cleaning the conductors before making the connection. These mistakes can all compromise the integrity of the connection. Another mistake is not using the correct tools. Using the wrong tools can damage the cable, lug, or breaker, and can also be dangerous. Always use the correct tools for the job and make sure that they are in good working condition. One more mistake is not following the manufacturer's instructions. The manufacturer's instructions provide important information on how to properly install and maintain the lug or breaker. Always read and follow these instructions carefully. A few more practical tips for working with 500 kcmil cable are: firstly, use a cable puller. Pulling large cables like 500 kcmil can be difficult and dangerous. Use a cable puller to make the job easier and safer. Secondly, use cable lubricant. Cable lubricant can help reduce friction and make it easier to pull the cable through conduit. Thirdly, use a cable bender. Bending large cables can be difficult and can also damage the cable. Use a cable bender to make smooth, even bends. Fourthly, use a cable support system. Large cables can be heavy and can put a strain on the electrical system. Use a cable support system to support the cable and prevent it from sagging. By following these guidelines and tips, you can safely and effectively work with 500 kcmil copper cable and ensure reliable electrical connections. Remember, when cutting the strands of a large gauge wire like 500 kcmil, the NEC, or National Electrical Code, doesn't explicitly dictate the exact number of strands to be removed for termination in lugs or breakers. The primary focus of the NEC is on the overall safety and performance of the electrical installation, and it emphasizes the importance of following manufacturer's instructions and ensuring proper termination techniques. However, the NEC does provide general requirements for terminations, such as the need for secure connections, proper torque, and compatibility of materials. These requirements implicitly address the issue of strand cutting, as improper strand cutting can lead to loose connections, increased resistance, and potential overheating, all of which violate the NEC general requirements. The NEC Table 310.15b16 and associated tables provide ampacity ratings for conductors based on their size, insulation type, and installation conditions. These ampacity ratings are based on the assumption that the conductors are properly terminated and that the connections are not adding excessive resistance or heat. If strands are cut improperly, the conductor's ampacity may be reduced, potentially violating the NEC requirements for conductor sizing. NEC Section 110.14 requires that terminations be made in a manner that ensures a good electrical connection without damaging the conductors. This section also emphasizes the importance of using connectors and terminals that are listed for the specific application and conductor type. NEC Section 314.16b addresses the space requirements for conductors in boxes and enclosures. When terminating large conductors like 500 kcmil, it's important to ensure that the box or enclosure is large enough to accommodate the conductors and their terminations without overcrowding. Overcrowding can make it difficult to make proper connections and can also lead to overheating. NEC Section 408.3 requires that switchboards and panel boards be marked with the conductor ampacity and the interrupting rating of the overcurrent protective devices. This information is important for ensuring that the electrical system is properly protected and that the conductors are not overloaded. NEC Section 408.41 requires that conductors entering a switchboard or panel board be protected from physical damage. This can be achieved by using conduit, raceways, or other protective measures. In summary, while the NEC doesn't explicitly specify the number of strands to cut from a 500 kcmil conductor, it does provide general requirements for terminations, conductor sizing, and overcurrent protection that implicitly address the issue of strand cutting. The NEC emphasizes the importance of following manufacturer's instructions, ensuring proper connections, and using listed equipment to ensure the safety and performance of the electrical installation. It's also important to note that local codes and regulations may have additional requirements for terminations, so it's always a good idea to check with the local electrical inspector before starting any electrical work. When dealing with high voltage installations, the number of strands cut and the termination methods become even more critical due to the increased risk of electrical hazards. High voltage systems operate at voltages above 600 volts, and the consequences of a faulty connection can be severe, including equipment damage, personal injury, and even death. The design and installation of high voltage systems are typically governed by more stringent standards and regulations than low voltage systems. These standards often specify the types of connectors and terminals that are permitted for use, as well as the methods for making terminations. In high voltage applications, it's essential to use connectors and terminals that are specifically designed and tested for high voltage use. These connectors are typically made of high-strength materials and are designed to withstand the high electrical stresses and temperatures that can occur in high-voltage systems. When making terminations in high-voltage systems, it's important to follow the manufacturer's instructions carefully and to use specialized tools and equipment. The terminations must be made in a clean, dry environment to prevent contamination, which can lead to insulation breakdown and electrical arcing. In some high-voltage applications, it may be necessary to use stress cones or other specialized devices to reduce the electrical stress at the termination point. These devices help to distribute the electric field more evenly and prevent premature failure of the insulation. Regular inspection and maintenance of high-voltage terminations are essential to ensure their continued reliability. This may involve visual inspections, infrared thermography, and electrical testing to detect any signs of deterioration or overheating. If any problems are detected, the terminations should be repaired or replaced immediately. Working with high-voltage systems requires specialized training and expertise. Only qualified electricians and technicians who have been properly trained in high-voltage safety procedures should be allowed to work on these systems. It's also important to follow all applicable safety regulations and to use appropriate personal protective equipment such as gloves, eye protection, and arc-rated clothing.